Hey class, so today we're going to be learning from chapter 6. There's two things we're going to be learning. More of a review. So yesterday we did the inquiry lab review, or the inquiry lab, and today we're just going to be reviewing some of those key concepts that we learned. Shouldn't take too long. And then we're also going to be learning lesson 1 today, and make sure you're taking notes on both of these. I have lesson 1 set up right over here. This is the inquiry lab review. So use one note page for the inquiry lab review and then another note page for lesson 1. Okay, so inquiry lab review, we have chapter 6, inquiry lab review as the title. Okay, that should also go into your table of contents. And then of course we have our main ideas column and our notes column. So to get started, we're just going to put review over here. And what we're going to be reviewing is first some operations and then sum, difference, product, quotient, which we talked a little bit about in class. So A plus B equals a sum. And I'm going to be using A and B as our variables. Okay, we talked a little bit about what variables are. Variables, we use variables. They are letters, okay? So they stand for an unknown number. So sometimes we don't know what a number is, so we're just going to use a letter, okay, in its place. So right now I'm just using A plus B to represent numbers, okay? So this is a sum as an answer to an addition problem. A minus B would be the answer. A minus B would be the answer to a subtraction problem, which we call a difference. Okay, A times B . So in this problem, A times B, we would have a product for our answer. Okay, it's an answer to a multiplication problem. And then A divided by B . A divided by B, our answer is called a quotient. Okay, it's the answer to a division problem. All right. So these are some, vocabulary words you're going to need to know. So I'm just going to put vocab and make sure you learn them. And then operations. Let's go over what an operation is real quick. So we learned we went over what an operation is. So an operation is everything that we're doing here. So A plus B, A minus B, A times B, A divided by B. So all these things, plus, minus, multiply, divide, okay, those are all operations that we do. They're called operations. Okay, and now let's go over expressions and terms. So again, these are all things that we went over in our inquiry lab yesterday. Okay, so an expression is a combination of numbers and operations. Is a combination of numbers and operations. So again, we know what operations are. Okay, it's going to be addition, subtraction, multiplication, and division. okay, what we do to the numbers, and then numbers, of course, we know what that is, 1, 2, 3, 4, whatever number you use. So we're going to show some examples of expressions later on. Hopefully we all know from our inquiry lab, though, what an expression is. And then let's go over what a term is, which is super important. So I'm going to just put a little border around that so we know that it's very important. So term, definition, each term of an expression, and we have the definition for expression, is separated by a plus or a minus sign. Okay? So each term of an expression is separated by a plus or a minus sign, okay, or addition or subtraction operation. So we're going to list some examples right over here. First, let's start with 4 plus 8 minus 6. Okay, so if we look at this, this is what an expression is, this whole thing. Okay, we have our numbers. It's a combination of numbers, 1, 2, 3. We have our numbers 4, 8, and 6, and operations. Okay, the operation is addition and subtraction, so we have our plus and our minus sign. Now we're looking for the terms, okay, and our terms are separated by a plus or a minus sign. So we have a plus and a minus sign there. So that means we have 1, 2, 3 terms. Okay, these numbers are all separated by plus and minus signs. So that means we have 3 terms. 1, 2, 3. So 3 terms in that expression. Now let's look at the next expression. 4 times 5 plus 6. Okay, so let's look at our definition of a term. Each term of an expression is separated by a plus or a minus sign. Okay, so let's look over here. Well, I see a plus sign. I don't see another plus sign or another minus sign. I'm going to highlight this. And even though this multiplication sign is an operation, okay, so it fits our description of what an expression is, which is a combination of numbers and operations, okay, even though this multiplication is an operation, okay, it does not separate a term. See right here, we only have plus or minus signs that separate our terms. So that tells us that this 6 is a term, and this 4 times 5 is 1 term. Okay? So that means we have 2 terms. One more example, okay? Let's say we had 8 times 3. Well, it is an expression. We have numbers and we have an operation, okay? But I don't see any plus or minus signs here. So that means it can only be 1 term. It's not separated. So it's at least 1 term. I know when I asked this question in class, a lot of you thought it was 0 terms. You held up your hand and you said, you know, I think it's 0 terms. This is considered 1 term, okay? It's at least 1 term. So now we have examples of what 3 terms, 2 terms, and 1 term looks like. let's move on to our next example, okay? Product of a sum expression. Okay, so again, product of a sum expression. Okay, so let me just show you an example of what this looks like. We did see it in our inquiry lab. 2 times 3 plus 4, and the 3 and the 4 are in parentheses. So this is a product. 2 times, we have our multiplication sign telling us that our answer is going to be a product, but it's a product of a sum expression. So over here, we have 3 plus 4 would give us a sum. Okay, but it's also an expression. We have our operation in numbers. Okay, so 2 times the sum expression, 3 plus 4. Okay, so that's how a product of a sum expression looks like. Now, you may be asked in this chapter, what are the factors? Okay, and you were asked in the inquiry lab. So the factors just to refresh our memories, is what you multiply to get your product, right? A factor times a factor equals a product. It's things that you multiply. Okay, so 2 would be one factor, and 3 plus 4 would be our other factor. Okay, so this is a factor and this is a factor. We are multiplying them. Whatever is in the parentheses, we do what's in the parentheses first. After we do what's in here, we would multiply this sum with this factor. Okay, so that's just a little review of our inquiry lab. I'm going to bring the computer a little closer in case you were able to see some of what I wrote. But we really were just reviewing some vocabulary, what an expression is, what a term is, so you have these as formal notes, and some examples for you. Okay, let's move on to lesson 1. Okay, so in lesson 1, we are studying powers and exponents. Okay, so to start off, we have already, hopefully we're all a little familiar with powers and exponents from our pre-test. When we were going over it, we did just a little bit of review, and I think maybe some from previous math classes you guys have taken, you should know what powers and exponents is, or at least have heard of them. Okay, so let's review what an exponent is first. So an exponent, okay, this is how it's going to look. 10 to the second power. Okay, that's one way that you could say this. 10 to the second power, or 10 squared. Our exponent is going to be the number that is raised, okay, in the corner of the 10. So, I'm just going to put a square around this. I'm going to say that's our exponent. So, this is where you write the exponents, okay, in this area above a number. And exponents could be any number, okay? It just depends, and it depends on what I'm going to show you in a few minutes. So 10 to the second power, that's one way to say it, okay? And this number, 10 is considered our base. It's our base number. So let's write that down too. Okay, so 10 to the second power, or 10 squared, 2 is our exponent, and 10 is our base. And then I want to go over a couple things that are misconceptions. So a lot of students would think, you would, to solve this, okay, to calculate it, they would think, oh, you just multiply 10 times 2 to get 20. That's not true, okay? So you can't just multiply 10 times 2 because this 2, the exponent, it means that there are 2 of these 10s and they multiply each other. So it looks like this, 10 times 10. When we have 10 times 10, we can rewrite it as 10 to the second power, telling us that there's 2 10s multiplying each other. Okay, so 10 times 10 equals 100, not 20. Okay, so it's important that you remember that. All right, let's talk a little bit about expanded form. Expanded and exponent form. Okay, so let's say we have the number, the exponent 5 to the 4th power. Once again, this would not be 5 times 4, okay? This exponent tells us that we have 4 5s, and they're multiplied by each other. So it would look like 5 times 5 times 5 times 5. I have 4 5s. 1, 2, 3, 4. So it's 5 to the 4th power. All right. This form right here, this is the expanded form of our exponent form. Okay. So I'm going to highlight this in yellow so we know it's our expanded form. And I'll highlight this in pink so we know it's our exponent form. Okay, so 5 to the 4th power means 5 times 5 times 5 times 5. And when you're multiplying it, okay, just take it one step at a time. So when I'm multiplying this, I'm first going to look at the first two numbers, 5 times 5. And you can do this in your calculator. Just be careful what buttons you press. So 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. Okay, so your answer is 625. So again, it's not 5 times 4, not 5 times 4, it's 5 times 5 times 5 times 5. And if you use your calculator, your answer is 625. Okay, so this is an example. This is our exponent form and our expanded form. Let's write a few more examples here. So if I had 3 to the 3rd power, okay, 3 to the 3rd power means 3 times 3 times 3. I have 1, 2, 3. I have 3 3s, so that means 3 to the 3rd power. And 3 times 3 is 9. 9 times 3 is 27. Okay, next one. If we have 4.1 to the 2nd power, or 4.1 squared, well, we'll get to the decimal part. Something you got to be careful with because it's a decimal. But since I have these parentheses around it, anything in the parentheses is going to be to the power of 2. Okay, so in this case it's 4.1. So in expanded form, it's going to be 4.1 times 4.1. And please don't try to do this in your head, because a lot of students will try doing it in their head and they'll multiply 4.1 times 4.1, and they'll think that they need to either add these ones and they'll get 16.2, or they'll think 1 times 1 is 1 and they'll say 16.1. But that's not true. So look over here. If we multiply our decimals, 4.1 times 4.1, this is from a previous chapter. We're going to ignore the decimal for now and just multiply like normal. So 1 times 1 is 1. 1 times 4 is 4. We're going to add a 0, okay, to hold a space. And then we're multiplying 4 times 1 is 4. And 4 times 4 is 16. Add those up. Okay, and then I'm going to add my decimal back in. So I'm going to count how many jumps I have. I have 1, 2, I have 2 jumps. So I'm going to add that back in. 1, 2. So my answer is 16.81. Alright, one more example using fractions. So if we have a half to the third power, this is how it's going to look. Half times half times a half. Okay, remember with fractions, if we're multiplying, multiply across. So we're going to do 1 times 1, which is 1, times 1 is just 1. Now we're going to multiply the denominators. We're just going to multiply across. So 2 times 2 is 4, and 4 times 2 is 8. So we get 1/8 as our answer. If looking at this form, exponent form, confuses you, then I would just write it out, expand it, put it into expanded form. Okay? One more thing I want to show you guys on this. If you are given like 8 times 8 times 8 times 8, okay, so if you're given expanded form, you need to put it back into exponent form. Just count how many 8s you have. So in this case, I have 1, 2, 3, 4. I have 4 8s, so that means I'm going to write it like 8 to the 4th power. Okay? 8 to the 4th power. That means I have 4 8s. 8 times 8 times 8 times 8. Okay. So, we only have 2 more things to talk about. Powers. Okay? So, we're done talking mostly about exponents, but we got to talk about powers as well. Okay, so powers, here's our definition, are numbers expressed using exponents. Okay, so earlier you heard me saying a lot like 10 to the 2nd power, or 3 to the 3rd power, 8 to the 4th power. Okay, so powers are numbers expressed using exponents. So we use those exponents to express powers. For example, if we have 4 to the 3rd power, okay, the way that we say it is going to be 4 to the 3rd power. If we have 4 to the 2nd power, and another way to say this is 4 squared, so we have 2 ways to say it. So 4 to the 2nd power You can say 4 to the second power, or 4 squared. Okay. You can also say this one as 4 cubed instead of 4 to the third power. Okay, so 4 to the third power, or 4 cubed, and then 4 to the second power, or 4 squared. And I'll explain why we can say 4 squared in just a second. So now that we know what exponents and powers are, last thing to talk about are perfect squares. Okay, so perfect squares are going to be these over here. I'm going to start listing them. 1 squared, 2 squared, 3 squared. Okay, let's start with these. So 1 squared, well, 1 to the power of 2 really just means 1 times 1, which is just 1. 2 squared, 2 to the second power, is going to be 2 times 2, and that's 4. 3 squared is going to be 3 times 3 is 9. Okay, so 1 squared equals 1, and 1 is a perfect square. 2 squared is 4, and 4 we call a perfect square. 3 squared equals 9, and 9 we call a perfect square. Okay, so in a common theme, 4 squared, you could go on and on and on for every single number. 4 squared is 4 times 4, which equals 16, and 16 we call a perfect square. Okay, it's a perfect square because you are literally making a perfect square. So square has side lengths that are the same, right? Its length and its width are the same. So here we have 1 squared, 1 times 1. Okay, if we imagine this as length, this is L, and width, okay, then we have 1 times 1. So 1 times 1 equals 1. Perfect square, it's 1. Okay, let's look at 2 squared. And I'm not drawing these squares to scale here. So 2 times 2. Perfect square again. Lengths are the same. Gives us 4. Perfect square. 3 times 3. Gives us 9. Okay? This is why you can say squared, because it makes a perfect square. Okay? Anything squared will make a perfect square. So I could keep going with this list. 5 squared. 5 times 5 equals 25. 25 is called a perfect square. 6 squared. 6 times 6 equals 36. 36 we call a perfect square. 7 squared. 7 times 7 equals 49. 49 we call a perfect square. And I'm just going to draw some dots saying you could go on and on and on. Okay, so just to review, an exponent, we learned what an exponent is, what a base, okay? This number 10 would be our base, and this number raised, okay, up here would be our exponent. And then we have expanded and exponent form. This is exponent form, expanded form. Some examples here. And then we understand what a power is, okay, 4 to the third power, or 4 cubed. And then we learned some perfect squares. You will have a little bit of practice in your workbooks if you have time. If not, we'll leave it for another day.